Hello chemistry kids, this is Mr. Brown. Today we're going to be doing a little bit more with equilibrium. We're going to use a model with these two bowls and some colored water to try to help you understand equilibrium even better than you do right now. All models have some issues. This one I really like. It does have some issues with it, but it works pretty well for understanding equilibrium. Okay, so what we've got here is in this bowl here, we're going to have our reactant. So these are our reactant chemicals, and then they will produce products, and these will be the product chemicals. Now, in the beginning of any reaction, you have to start out with reactants. So the reactants are the green water right here. So I'm going to put this green water in here. And so these are, we're pretending these are all the chemicals all the reactants that we're having react, okay? And so, so during a reaction, there are both reversible and irreversible reactions. So if we had an irreversible reaction, what would happen is this. There would be some reactants that would react, and then they would produce products, okay? And then more would react, and they'd produce products. And over time, the reaction might slow down, and you can see that there's going to be less and less in here. It might slow down because we're running out of reactants. And so as reactants start running out, we get less and less of them reacting. So the reaction will actually slow down over time because we're running out of reactants. Okay? Now that's for an irreversible process or an irreversible reaction. We've got reactants becoming products, and the products aren't going back. Okay, so now let's start over again. And so in this case, we're going to say that we have a reversible reaction. So what that means is that the reaction can go in both directions. Now, right now, when we're at our starting point, we just have reactants. We have no products. So the only direction this can really go is in the forward direction. And so we have some reactants react, and then they produce products, okay? Now that we have some products, because this is a reversible reaction, the products can now become the reactants. And you can see that, okay, this is how fast the forward reaction is going. It's going quite quickly. And this is how quickly the reverse reaction is going. There's very little in there. And so we've now got a reaction that is reversible. And so as we go forward, during this time, the reaction will continue on and on and on. Now, is this at equilibrium? Not yet. At equilibrium, the rate of the forward reaction would be equal to the rate of the reverse reaction. So let's see if that's the case. So right now, you can see that my reverse reaction is almost to the top. So let's see how fast it is going in the forward direction. See, it's still overflowing. So the forward reaction is still faster than the reverse reaction. Okay, so we got to keep going to see if we can find that equilibrium. When this reaction gets to equilibrium, or this process gets to equilibrium, the rate of the forward reaction will be equal to the rate of the reverse reaction. And so right now, like I said, the rate of the forward reaction is just much higher than the rate of the reverse reaction. But I think we're going to start getting closer and closer as we go. Also notice what's happened to the amount of the reactants and the amount of the products. The amount of reactants has gone down quite a bit. The amount of products has gone up quite a bit. In this case, it looks like we're going to end up with an equilibrium that has a lot more products than it does reactants. But that's not always the case. In some reactions, there's a lot less of the products than there are of the reactants. Okay, now let's check to see if we're at equilibrium. So this little cup here is almost filled. And if I take this, we're almost filled there. So we are now at equilibrium. So how do we show that on paper is we would change the forward arrow to a forward and reverse arrow. So now this is at equilibrium. So what's going to happen here is if I just keep going, and this is what's happening to the particles, it's not that at equilibrium the reaction actually stops, it's there's still the forward reaction and the reverse reaction both happening. It's just that they're both happening at the same rate. And so what ends up happening to the amount of the reactants? Well, for every bit of reactants that become products, there's the same amount of products becoming reactants. And so over time, the amount of reactants will no longer change, and the amount of the products will no longer change. And so I could do this for the rest of the day, and it would still stay the same amount of products and the same amount of reactants, okay? And so this is the two key points for equilibrium that you need to understand. The first point is that equilibrium exists when the rate of the forward reaction is equal to the rate of the reverse reaction. The second important point is that even though the amount of the products and the amount of the reactants at equilibrium are not equal, they will stay constant over time. Okay, again, what that means is that if I keep going, because the amount of liquid in this mug is the same as the amount in this little cup, okay, the levels of water are not going to change. Okay. Oh, sorry. Okay. I hope this has been helpful to you, and please let me know if you have any questions.